did we get a chance to look at the second derivative test? I sort of went into it on that video. What is the purpose of a second derivative test?
To determine whether or not the function concaves up or concaves down.
Exactly. So the second derivative test it is used to determine concavity. If we know that there is concavity, do we know what concavity is from algebra? That is concave.
A curve. But you have to know where it curves or what. It's hard to describe.
Is it up or down?
Yeah, it goes up or down depending on whichever.
Right, so if you have a curve of that sort, is it concave up or down?
It's up.
It's up. If you flip it, it's going to be down. But if you know that there is concavity, also guarantees you a minimum or a maximum. Agreed?
Yeah.
If you have a U shape, which is up, then there is a minimum. So some people would like to use the first derivative test and find the minimum and be happy with it. Some would go for the second derivative test and determine the maximum, minimum, increasing, decreasing, everything in one shot. Does that make sense? So even before we start this problem, we should know the type of function this is.
Quadratic?
It's quadratic. If I graphed, what would it look like?
Parabola? Yeah.
That's a parabola?
No.
That.
No,
Right? It's either that or that. So of the two, which one do we expect it to be?
the negative concave.
So it's concave up or down? It has to be down. Easier way to recognize that is the leading coefficient. If it is negative or a quadratic function, concave down. If that is positive, it would be concave up. This is the process to find or determine concavity. Step one, we have to find the first derivative. It's pretty easy here. That would be negative 8x plus 3. Step two, what is the second derivative? Negative 8. Last time when we set the first derivative equal to 0 and solve for x, we get the critical values or the critical points. In this case, if we set the second derivative equal to 0 and we solve for x, that would give us the points of inflection. Now, what is a point of inflection? The point of inflection is a point where the concavity changes. In other words, it has to go from up to down, down to up. Then we call it an inflection point. And where does it happen? They occur at places where f double prime of x is equal to 0, or it doesn't exist. Here's a question. How many points of inflection would that function have?
3.
3? Okay, enlighten us, Liam.
No, actually. No,
Oh, it was
actually,
you? Okay.
Yeah. I'm just making extra sure that it was 3. So what's going to happen then once you set fx to 0 and whatnot? You're just going to have to input. Gosh, how does it fill my head? You'll just have to input the function. Never mind.
I want you to read this carefully. A point of inflection is where the concavity changes. Even before we did all this, I asked you a question. Is it going to be concave up or concave down? And Bracken said, concave down. Now, is there a point where the concavity will change?
At the minimum?
Huh?
At the minimum or maximum?
No, the concavity. So it has to move from up to down or down to up.
So the 0 then?
Huh?
It doesn't change?
It doesn't change because it is a parabola and it is always concave down. Yes? There isn't a place where it's going to flip from up to down or down to up. So how can I verify this? If I set the second derivative equal to 0, right here, the second derivative is negative 8. Setting that equal to 0, do we, is that acceptable? No. Did not work. That should sort of tell us that there is no point of inflection. In other words, the concavity doesn't change, but that does not imply that the concavity does not exist. Clearly, it is concave down. All we are saying is that it is not going to change from down to up or up to down. So if you graph this in your calculator, it is a parabola will look like that. And I know where that value is going to be. The maximum. Let's see if you can tell me. Where is that big point? The answer is right in front of you. Think back, how do we find the minimum or the maximum?
Look at how the line's going up or down.
Right, but how do we use calculus to find that minimum or maximum? This is from last time.
we solve for f of x to 0, f of x prime to 0.
So we set the first derivative equal to 0. In other words, I would have negative 8x plus 3 equals 0. Yes?
Yep.
Which would mean negative 8x is equal to negative 3.
Which turns into x equals 3 over 8.
So that point right there is 3 over 8. Good?
When you set it to 0 and solve for x, is it always going to be that middle number on the graph?
It should always correspond to the minimum or the maximum.
Okay.
Yeah. So it depends on how many minimum or maximum you have, but it would always be the middle number, right? If a function is going up and coming down, the maximum is right in the middle, right? So what is our conclusion? The curve is increasing for what values of x?
Negative infinity to 3 over 8.
Should we include the 3 over 8? In other words, should we put a square bracket?
No.
No.
Yeah.
And it is decreasing.
3 over 8 to infinity.
Maximum is at x is equal to 3 over 8. Yes?
Yep.
And last conclusion, it is concave down.
Yes.
Full x in. It's concave down. For what values of x is this function concave down?
Negative infinity, positive infinity?
Negative infinity to positive infinity. Because it is concave down everywhere. Don't want to graph, because this is easy. The next problem, I'll show you how to use a graph. Very first step is to find the first derivative. And what do we get?
9x squared minus 4x.
Good. Let's just go ahead and find the critical values. This way we know or get an idea as to what the function is going to look like. We set f prime of x equal to 0. And we solve for x. algebra. How do we solve that? Liam?
Well, we're gonna take out the x first.
Okay.
Nine next to minus 4x. No, it was just paying attention there. It's nothing.
How do we solve? Should know algebra. You have two factors. If you multiply the two, you get 0, which would imply you set the first one equal to 0, which gives us 0. 9x minus 4 equal to 0, which would imply 9x is equal to 4. So x is 0 and x is 4 over 9. Those are the two critical values. From last week, how do we determine if a critical value corresponds to a minimum or a maximum? Can I erase this? When you do the homework or the exam, typically they just say, do the first derivative test or the second. I'm doing everything for better practice. How do we determine if each critical value corresponds to a minimum or a maximum?
It falls between the domain.
Oh.
If it falls between the domain.
Can't hear you.
Sorry, if it falls between the domain.
Well, it has to fall in the domain, right? But how did we pick out last time? Zero is one of them. 4 over 9 is another.
Just
Yes?
a number on each side.
We pick a number on each side. Give me an easy number below 0.
-1.
-1. And where should we plug in that -1? In the original function or the derivative?
The original function.
No, the derivative. That is the most common mistake. What students do. So -1 squared is 1, and 9 times 1 is 9. -4 times -1 is +4. I get 13. Is 13 a positive number?
That's a positive number, yeah.
Okay, so is the function increasing or decreasing?
Increasing.
It is quite unfortunate that we have to pick a number between 0 and 4 over 9. I guess I'll pick 1 over 4. Sounds good. Take that 1 over 4 and plug it in the first derivative. We have 9 times 1 over 4 squared minus 4 times 1 over 4, which is 9 over 16 minus 1. If you took the common factor and simplify, you'll get -7 over 16. Is -7 over 16 a positive number or negative number? Negative. So should the function be decreasing or increasing? Decreasing. Easy number, bigger than 4/9. 1. Nine times 1 squared minus 4, which is 9 minus 4,
5.
5, which is positive. So on that interval, is it increasing or decreasing?
Increasing.
Good. So the function is going up, makes a turn, comes down, makes a turn, goes up. With me? At 0, is there a maximum or minimum?
Would it be a local max?
Yeah, local, thank you.
Yeah.
So local max, right? Turns, comes down, turns back up, minimum. So the function is increasing for x in
Negative infinity to 0, not including 0.
There's a 4 ninths, but not including 4 ninths to infinity.
and what goes in the middle?
A decrease. No, you.
The U thing. Yeah, like that. There you
That
go.
stands for unit, right? This or that. It is decreasing between 0 and 4/9. Local max at x is equal to 0. Local min at x is equal to 4/9. Good? So pretty much we've got an idea about the function. If I have to arbitrarily go with this function, I'm just going to say it's going to look like that if you graph it. Yes? So that point is 0, that point is 4/9 on the x-axis. If I asked you to take a guess, what do you think the concavity changed? In other words, it moved from up to down at some point, some value of x. I just want you to take a guess.
0 and 4 ninths.
Somewhere here, right? Because if it was like that, it became concave up, which means it has to be here. How do we find that?
Second derivative.
Second derivative, ooh,
Set to 0.
the second derivative
18x minus 4.
18x minus 4. Can I erase this down?
Yes.
Yes.
which would imply 18x is equal to 4. It's 2 over 9. Yes? Even before I started this, I made a guess, or you guys made a guess, that it will be between 0 and 4 over 9. Is 2 over 9 between 0 and 4 over 9?
Yes.
Yeah, exactly halfway in the middle. So that is point of inflection. And we, yes,
Will the point of inflection be like exact middle every time?
usually with algebraic functions, it'll work that way, but we can't take it for granted. It won't work that way always. We found this, but we still want to verify if in fact the concavity changed. And that's the part of, or that's the concept behind the second derivative test. So 2 over 9 is right over there. Yes. Now we want to pick an easy number less than 2 over 9.
0.
0. And I'm going to plug that in, take a guess, second derivative. So 0 definitely is less than 2 over 9. I plug it in the second derivative and I end up getting negative 4. Yes. It's a negative number. Since it is a negative number, it's concave down. Pick an easy number to the right of 2 over 9. 1. Plug that in the second derivative, you get 18 times 1 minus 4, which is 14. 14 is a positive number, yes?
Yep.
So, concave up. So my guess as to what this function is going to look like is it's going to come down, turn, and go up. And that's just my guess, just by doing this. Let's see if the calculator agrees with us. Okay, so the function that we had was 3x cubed. Yes. Minus 2x squared. Plus 1. So you look at that and you say, well, that picture doesn't look like any of the conclusions that we had, right? So either that is wrong, or that is wrong, or you're not seeing something properly, right? What do you think the issue here is?
Not seeing something properly.
Not seeing something properly. So this is how you make mistakes in the exam, because if you simply rely on the calculator, you look at that and you say, I don't see a minimum, I don't see a maximum. What went wrong? Now, we need to zoom this so we get a better picture. So what is a reasonable area to look at? The x values.
Probably negative 2 to positive 2.
Probably negative 2 to positive 2. Let's try and see what happens. And maybe we shouldn't have those y values really large, because that may not help us either. Very subtle. Agreed?
Yes.
So, maximum, minimum, right? If you didn't know any of that, you'd be sitting here for 30 minutes going back and forth in your calculator trying to find that point and that point. But if you start with that, it will give you an idea immediately as to where to look. I can zoom this a bit more to get a better picture. Let me change the x and y value, the y limit to -1 to +1. Things are starting to look better. Agreed? So how did we determine the maximum and minimum last time? So we went to second trace. It's asking for min, max. So let's start with the maximum. And the maximum seems like it's right over there. So you've got to go to the left of the maximum, enter. To the right of the maximum, enter. We already know where the maximum is at, it's at 0. Let's see if the calculator will do the job for us, enter. You see that and you say, whoa, that's not 0. What happened?
Was it because we picked 0 as a point? It wasn't like an exact point. It was just kind of like a reference while we were doing the calculus over there.
No, the calculator is giving me that the maximum is happening at that value, right? But that value doesn't look like 0, so what are we missing? I'm going to argue it is in fact 0. Why?
Well, that number is incredibly small.
That number is incredibly small. It's -1.088 times 10 raised to -6. So it's a very tiny number. Another disadvantage of the calculator. A calculator can only give you an approximate value. It is not going to give you the exact value. Calculus, on the other hand, will give you the exact value. Does that make sense? Now we can go over to the other side and find the minimum. So left bound, I can see the minimum is right over there, so to the left of the minimum, enter. To the right of that minimum, enter. Let it make a guess. Getting the minimum to be at 0.444459. And the corresponding y value is 0.8683. In your calculator, type 4 over 9. 4 over 9 is 0.4444. Good. The drawback of the calculator is not going to give you the point of inflection. Now, there are ways to get it, but I just don't want to complicate things. If I simply have to rely on the calculator, there are a few other steps that I can go from here and actually find the point of inflection using the calculator also. But then it's just going to complicate things. Once you find those 2 points, you can take a guess on an exam or the homework, or probably the exam, not the homework. you have a bunch of answers, but even before we started this process, we had a 0 there, 4/9. Our guess was, okay, it has to be between those two. So on an exam, you can get rid of all the answer choices that doesn't fall between 0 and 4/9. Does that make sense? Process of elimination. If you understand it, it is your friend. Any questions on what we did?
So the point of inflection is the point right between where either side starts to concave. A
The
certain way.
point of inflection is the point where the concavity flips.
Okay.
So it was concave down, flipped, concave up.
Will the point of inflection always be found at the second derivative?
Yes.
Okay.
I'll just write the formula before I end. So the function is concave up for what values of x?
Negative 0.
0,
2 ninths.
2 ninths. Should we include 2 ninths? No. Oh, meant to say concave down. And f of x is concave up.
Starting from 2/9, not included to infinity.
Are we clear? Yes. So next time I'm going to do a few more problems on this before we can move on to the next topic. Are we clear? Good. It's a good place to stop. If you have questions, talk to me.